Welcome to another Spirit of Aviation Week interview. I'm Steve Buss, the volunteer chairman for Interview Circle during EAA AirVenture Oshkosh. And please join me in welcoming this time around a very distinguished panel of experts. The X-Men, we're going to call them, are all involved with the X-Plane program with NASA, the National Aeronautics and Space Administration. And what we're going to do to just kind of get everybody familiar with who you're looking at on the screen is just go around Brady Bunch style and find out a little bit about each of you and how you got involved in aviation and in NASA and what you do for NASA. We'll start with Bill Berry, who's got a great job, the chief historian for NASA. So, Bill, welcome.
Hey, thanks, Steve. Good to be here. I started my aviation journey, I think, probably when I was about 4 years old in 1962, watching John Glenn fly into space. And, you know, the excitement of that, I was just hooked. I wanted to be involved in the space program and things. And like many kids who grew up in the 60s, I thought that the best way to do that was go off and be a military pilot and then try and get a job at NASA. When I got to the Air Force Academy, I discovered that engineering and I were not destined for a long, successful future together. So I switched majors, but I went off and had a good Air Force career. I flew the KC-135 for about half my career, and then I spent most of the rest of my career either in graduate school or back teaching at the Air Force Academy. So when I retired in 2001, I was able to land a job at NASA at long last, and I worked in our international office for about 9 years, and then the last 10 years I've been the chief historian. And what a lucky guy I've been to get so many great jobs and to have a chance to fly airplanes and study the history of them and do all kinds of cool things.
Now, Nils, tell us a little bit about your background and how you got involved in aviation and in NASA.
Somewhere in high school, I decided I wanted to be a test pilot. It was actually an instructor handed me the book, The Right Stuff. I read it, couldn't put it down, and decided this is what I wanted to do with my life. So mapped it out of how I had to go and do that. And so ended up going to the Air Force Academy like a couple other people here on this panel. And went there, was a soaring instructor there originally, then graduated. Flew T-37s as an instructor pilot after UPT, off to the U-2, then off to test pilot school and finished that. They don't know what to do with a T-37 U-2 guy, so they sent me the F-15s then, so go figure. So I flew the F-15 in flight test at an airplane no one's ever heard of called the RU-38, made by Schweitzer. I was also on the T-38C avionics upgrade program. Flying 3 different airplanes in flight test, that opened the door to let me go do an exchange with the Navy, flying and teaching at the Pax River at their test pilot school. When I was done with that, I came back to the U-2 as the commander of the depot and flight test unit down there in Palmdale. Finished out my Air Force career as the deputy ops group commander up there at Edwards. If you notice, I never left the cockpit, in 20 plus years there. And then went down the street to NASA, where I've been there for about 13 and a half years, getting to work on all kinds of different really cool projects.
Great. All right. James, tell us a little bit about your background.
Hi, I'm Jim Less, and I, growing up, was interested in everything space and airplanes, but didn't necessarily think about being a pilot. I showed up to college on an ROTC trip with the Air Force, had never been in an airplane in my life. Thought I was going to be an engineer, raised my hand at the wrong time, and next thing I knew, I was on my way to Air Force pilot training, and spent a long career doing that. Started off flying F-111s, got to fly the F-117 for a while, T-38s. Went through the Air Force Test Pilot School at Edwards Air Force Base, and then tested F-16s for a number of years. Got to teach at the Air Force Test Pilot School a number of times during my career. Continued to fly F-16s. Did a stint in a highly modified business jet over Afghanistan. Retired in 2010 when Nils offered me a job to be a test pilot at NASA. Couldn't pass that one up. And so for almost 10 years now, that's what I've been doing. And I'm currently one of the project pilots on the X-59, Nils understudy, ready to step in at a moment's notice.
Well, that's good. We're going to talk about the X-59 a little bit later on in this program, but now we'll move on. Wayne, go ahead.
Hello, Wayne Ringelberg. My dad was a diver in the Navy, so I figured I needed to go into the Air Force and be a pilot. So I went to the academy and ended up going to pilot training after that. Flew tankers mostly, then flight test was mostly multi-engine aircraft, but some high performance. Did that for a while, both as a active duty and civil servant with the DoD. Gone with NASA about 6 years ago, flying a bunch of different things. And about a year ago, took over as the chief pilot from Nils. Also been the number 2 guy on the X-57 since we started that just years ago. Basically my background.
All right. And Hernan, why don't you tell us a little bit about your experiences?
Sure. Thanks for having me. I'm one of the civilian pilots that we've got at NASA. I was not in the Air Force, but my parents took me to an air show when I was a kid, and that kind of lit my fire. I did everything I could to get into a cockpit, so I was one of those kids that would find an airplane before driving a car. And I actually fueled airplanes when I was growing up through high school, and I got to fuel the NASA King Airs that I fly now. So that's a pretty cool story on its own right there. But in my aspirations, I got trained up to fly the Predator. It's the unmanned air vehicle that the military used pretty heavily. And I started traveling the world. And in about 2005, NASA got one. So I came on board there and subsequently got trained up in the Global Hawk, a really large unmanned aircraft that does research science missions, mostly over big storms. We've been doing that for a while over the Atlantic. So I've been lucky to be cross-trained in many small UAS there at NASA. So I'm the UAS person.
Excellent. Well, I think we're going to start with Bill and kind of set the scene for us. NASA has had a long history of research because a lot of people think of NASA simply as spaceflight, but it's national aeronautics and space. So, Bill, tell us a little bit about the program and how it's evolved through the years.
Yeah, well, aircraft research is something that NASA was built on. The National Advisory Committee for Aeronautics was founded in 1915 to help the United States catch up with Europe, actually, on aeronautics research that accelerated just prior to World War I. And then at the end of World War II, the NACA partnered with the Air Force in particular and the Navy as well to do high-speed research. And with a new kind of vehicle, with a experimental, purpose-built for research kind of airplane that acquired the name X vehicle. The term X plane is kind of confusing because there have been X planes that were helicopters, and X planes that have been missiles, there have been X planes that weren't called X planes; they called something else, like D558 or whatever the designation was. So there's lots of different things there, but I think we all know what an X plane is. It's this purpose-built experimental vehicle designed to do research. And of course, the first one was the X-1, and flown in 1946 to break the sound barrier. And one of the interesting things about the X-1 is that the reason that program was started, one of the many reasons that it was started, but the primary reason from the NACA perspective was that it was they're having problems getting supersonic speeds and good data off of wind tunnels. And the problem is called choking, where the supersonic shock waves would bounce off the model and then off the walls of the wind tunnel, and they were getting bad data. So at one point they thought, well, we're not going to be able to solve this problem. We've been trying to for a couple of years. The only way we're going to be able to test this stuff is to actually fly an actual airplane. And then that's the genesis of the NACA's involvement in the X-1. And then, of course, the program grew from there. And in the 50s, there was a wide variety of X vehicles. I think we've got a picture here of the ramp in 1953 at the Flight Research Center. And to me, the coolest plane on there is the X-3, which is, I later was disappointed to find out was probably the worst flying X-plane ever. We could ask some of the other guys on the panel about that one, but it was underpowered and didn't do what it was meant to do. But there were a wide variety of planes aimed at specific things. And of course, the most famous X-plane is probably the X-15, We've got a picture of that as well with the famous Bill Dana standing in front of it. The X-15 was a very long-running program. It started in the 50s under the NACA in the Air Force, and the Navy was involved as well. Highly successful program, flew for 10 years, probably one of the most successful flight test programs ever in terms of the quantity and quality of research material that was gathered from the X-15. And then throughout the years that followed, people sort of thought the X-plane thing vanished, but we were still flying a variety of different kinds of airplanes through the most recent years. There's a picture of the ramp at what was in Dryden Flight Research Center in 1997. You can see the variety of vehicles, including unmanned aircraft systems there, and other X vehicles and repurposed military aircraft of various sorts that were or were not called X planes at the time. And of course, just a couple of years ago, NASA decided to go back into the X-plane business in a serious fashion with two new airplanes that we're going to talk about tonight.
Excellent. And you did mention the X-15, and I think maybe in the public's eye that was the epitome of that, because that really was quite an impressive program, and quite a few pilots who were in the X-15 program ended up becoming in the Gemini and Apollo program, and also flew the space shuttle as well. So it's definitely had a long and storied history.
Yeah, the X-15 was quite a vehicle, and of course, famously, Neil Armstrong was one of the few people who was lucky enough to fly it. And sadly, the last remaining one is Joe Henry Engel, who's
Joe Engel
went from being the youngest astronaut-rated person ever to flying the space shuttle on several missions. So quite a program.
Yeah, and it just absolute trivia right here is that Joe actually earned his astronaut's wings in the X-15 on June 29th of 1965. So there's your history for today, right?
There you go. You beat me to it.
Well, Wayne, now is in your role, how do you manage all the different vehicles and pilots that you have under your wings, as it were, because it's everything from supersonic flight to unmanned aerial vehicles. So how do you keep everything, all the balls in the air?
Yeah, no, that's an outstanding point, because although the focus here is on the X-planes, we have quite a lot of flying that goes on at Dryden, or now Armstrong. The aircrew branch, we have about 30 aircrew of different types. We have pilots, flight engineers, navigators, and we have both full-time and part-time, contract and civil servants. So it's a very diverse force from that standpoint. A lot of our flying is, most of our flying is in two main directorates of NASA, if you will. So airborne science, we have the SOFIA aircraft, DC-8, ER-2 does a lot of airborne science, which is most often earth science. Obviously, SOFIA looks at astronomy type stuff. But most that's earth science type platforms, looking at our Earth, imaging our Earth using aerospace. And then we have our aeronautics research, where we do a lot of flying in a multitude of different airplanes. And then part of that, and obviously a very important part, is the X-plane type activity that we're doing. And we're, as mentioned, we're getting into that quite a bit more now. So we have 5 named, basically, research test pilots. So a lot of our pilots have test pilot background. We have 5 of them that are fully employed right now as research test pilots. Those would be the ones that we would assign to this type of activity. So primarily, that's sort of how we manage the branch. I have several deputies that help me with the different types of airplanes. And of course, we'll have a lead pilot on each airplane that is fully responsible for that particular airplane. Since, although I'd love to be the guy flying them all and being in charge of them all, it's a little too much for me. Nils maybe did a better job back when he did, but it's a little too much for me.
So do you get to fly any of the aircraft now, even in your management role?
I do. Nils, Nils, I say he sold me on the job. He's like, hey, why don't you come do this? And, after we changed cubes, basically, I moved in the office, he moved into the cube. He was smiling just a little too much. So the good news is I still get to fly. So It's maybe not quite as much, but it is fairly important. At least the leadership here understands that the chief pilot needs to be, hands-on with what's going on with the operation. So it is a fair amount of flying still. So that's good.
Very
but
good.
I got to keep after all these guys to make sure they don't screw up. So
there you go. So we've mentioned it a couple of times, and Nils, we'll let you tell us more about the X-59 program and NASA's research into supersonic flight.
It's really long. It's almost 100 feet long. It is designed to produce a sonic thump instead of a sonic boom. So the whole purpose that we have for the X-59 is to try and reset the regulation for overland supersonic flight. Right now, you can't go faster for civil aircraft, faster than Mach 1 because of the boom it produces. So we have, a speed limit based on sound. And we said, well, why not base the sound limit on sound? Because we think we can design an airplane that won't produce that really loud bang or boom that we get. So over the years, we've been doing maneuvers in an F-18 that could produce a loop. And we really needed to prove out the technology and do it, with a full-scale airplane. So that is where the X-59 comes in. And the whole idea is to go out there and get the data. So you'll see it eventually coming to a town near you. Hopefully Oshkosh one day. We'll see. It'll be tough getting into that runway because it needs a lot of runway. But we'll see if we can come to a town near you, and we'll be using the general public as part of our science to get the data. So they'll be telling us what they think of the sonic thump.
And Jim, describe, if you can, is there a typical flight profile that you use while flying the X-59 to try and retrieve the data that Nils was talking about?
Well, that's one of the things we're working on developing right now. The X-59 is not flying yet, obviously. We are working on a simulator, and that's one of the things that Nils has me working on. We're developing that profile, but basically we're going to take off, climb up to altitude, somewhere in the neighborhood of 55,000 feet, accelerate out to about Mach 1.4, and make hopefully 2 different passes over a population center on any given sortie. The scientists, for accuracy of the survey data, want a certain amount of time between these passes, so that I guess the public maybe forgets about the first one or isn't quite sure when the next one's coming. And then we'll make a second pass, generally over the same area, and get about 2 passes on any given flight. The plane's going to be short on gas the whole time. Every flight is going to be about an hour to an hour 0.5 at the most. Every profile is going to look very similar once we've developed that. Get up on altitude, make the pass, wait for a little while so that it's not obvious when the next boom is, and make a second pass, and then head on back to land.
Now, will these flights be conducted just in one specific area? When you say you're coming to a town near you, or will you spread this out across the country?
We are going to spread it out across the country. Obviously, all the first flights are going to be in the Edwards area, making sure the airplane's cleared, safe for flight, and that it can do what we expect it to do, and the scientists can get a good baseline on actually how loud the sonic boom is. But then the goal is to take it out around the country. The scientists want to see different environmental regions, different weather patterns. So we're going to have hot and humid. We're going to have cold and dry, hopefully. A mix of different types of weather, because that does affect the sound of the boom that reaches the ground. We don't know where we're going yet or exactly how many different places, but over a couple of years, about a 2-year period, we are going to get out around the country and fly this over different population areas.
Is there a timeline for when the flights will start?
Nils, are you hearing this? Okay, I'll jump in. So schedule, like anything, is in flux. The original goal was to fly in 2021. The COVID pandemic has not helped the timeline. Our Lockheed partners are working very hard to keep working on the plane and continuing to build it during this time, but it has set us back a little. So
what's the technology behind the thump? And remember, you're talking to a person here, so I've heard things go boom, but how are you? Is there a way you can describe how you're modifying the boom into a thump?
Okay, it's basically the shape, and as Nils said, this is very long. A normal supersonic airplane has a strong shockwave off the nose and a strong shockwave off the tail, and those two merge as they head to the ground, and you get a pretty loud boom. They've shaped the X-59 so that you get a series of weaker shocks all along the length of the airplane, and that aren't going to merge before they get to the ground. So you're just spreading the same amount of sound out over a slightly longer period. Instead of a sharp crack, it's more like a thump. And our scientists tell us that it's going to sound like a car door closing at the house next door instead of a shot or a crack of lightning or something very distinct like that.
So instead of rattling the windows, it'll just be like the noisy neighbors.
Yeah. Well, my neighbors are noisier than that, but
okay,
that's another story.
So obviously the commercial applications for this will be, I think, would be in some pretty incredible aircraft that could use this technology to shorten, obviously, commercial flight times.
Then that's the whole goal of this.
Right.
Basically to cut the time about in half from a standard commercial airline now.
So of course the Concorde is the most famous supersonic aircraft, but how long has NASA been sort of researching or working on this problem of the sonic boom and especially over populated areas?
Oh, that would be a good question for Nils if he can hear that, because he's been on this project longer than I have.
Yeah.
Oh,
so,
that's a good
guys,
question. For how long have we been working on quiet supersonic flight? Decades. I would say ever since people suddenly realized they really didn't like the boom that was happening, we've been trying to figure out how to make it quiet. So there's a plane down in Florida, down not too far from Kennedy Space Center, that was one of the first ones that they modified an F5 for the shape. And that was at least, let's see, I've been in NASA for 13 years, so that's probably 20 years ago at least that we were looking at that. We've also been looking at how the boom travels through the atmosphere so that we can predict what the boom levels will be when it gets to the ground. So there's so it's been at least 2 decades, but I would guess it's even way more than that. So pretty much as soon as they determined that it wasn't, when the Concorde could no longer fly over, supersonic over land, soon after that, everybody said, well, and there must be a way to, to change this. So I'm guessing not that long after that.
And we're actually getting much closer. The road ahead is much shorter, it seems, than the road behind us as far as being able to quiet the sonic boom. So, Jim, is there anything in the program that's just absolutely unique that you've run into that you haven't come across in any of your other flight testing?
Oh, well, I think everything about building an X-plane is unique, but the most gratifying part, I guess, about this is that I'm in almost on the ground floor. Nils was working on it a little bit before I got there, but we've been involved through the formulation of the program, the design, the building of it, and then we're going to get to test fly it and then hopefully fly it around the country after that. Certainly as a military pilot, you do your 2 or 3 year assignment at any one location, and then the military moves you on to your next job. And so you don't see an entire program from start to finish. And that's one of the neatest things about this. Plus, the X-59 just looks really cool, and it's going to go fast.
Well, now we're going to transition from the X-59 going really fast to another program that's cutting edge as well, and that's electric flight with the X-57. So, Wayne, we'll turn things over to you to tell us a little bit about the X-57.
Sure, thank you. I'm happy to talk about a real X-plane, X-57. So the X-57 is NASA, our agency's first fully electric airplane, as well as probably our first crewed airplane in a very long time. We are definitely excited about that. Its primary purpose is to help develop the standards for basically fully electric aircraft, as well as distributed electric propulsion type aircraft. You can see on the wing there's several small motors. Those are technologies that are going to be used throughout urban air mobility, and the whole concept of hopping in a vertical lift something up to take you around. Those are likely all going to be electric powered. So developing the standards on how to help design, certify them for safety, and manage those kinds of systems is kind of its main goal. It's, as a design driver, the goal was to be basically 5 times more efficient than the base airplane it was planned off of, which is a twin engine piston turbo, or a piston airplane, a Tecnum P2006. So by putting in electric motors, distributing the motors across the wing, helped make the wing a lot thinner. So to be able to hold the landing speed, you could blow air over the wing to not have flaps, basically. So that wing could then be smaller, and then they move the cruise motors out to the wingtip, which is a more efficient location. So using those sort of 3 ideas should develop about a 5 times increase in efficiency. Those are the drivers to get us to try and make it a little harder to have an electric airplane instead of just going easy with it. So we're hoping, the plan is to do it in 3 phases. There'll basically be 2 different mods, basically. So the first one will be effectively the stock airplane with electric motors and batteries inside it. And then we'll put a new Mod 3 wing on it, which is the slender wing with the props on the wingtip, the electric motors on the wingtip. And then the Mod 4 is with all the distributed electric motors working. It's kind of the build up to it.
Was there a particular reason why you chose the Tecnum as the sort of the base of the X-57?
There was a fairly significant study to look at something that was sized right. I mean, they wanted a twin engine airplane. They needed a particular size. This one met all those criteria. So it was a logical choice. Fairly modern. That was something they wanted as well. So that's what kind of drove us to that particular airframe. I probably could have picked other ones, but that's the one that seemed the most least risky at the time and met the objective.
So one of the challenges, at least that I've read about with electric power, is battery technology. And you haven't mentioned anything about that. You've talked about the motors and the wing and everything, but how is the problem with batteries?
Yeah, that is a fair point. So electric power, unlike normal gas power, to have that kind of energy density, it takes quite a bit more weight. Battery technology is not at the same level of energy density as say fossil fuels are. So that's a bit of a challenge. We went with a stock battery, which was effectively a AA battery that was a lithium-ion battery that was stock, right? So, but that's the only thing that was stock. The whole buildup of it, how we were going to put it together, how we were going to keep one from setting other ones off if there was a thermal runaway, all that was leveraged off of existing technology, but new to this design. So it's about a 500-volt system in there with a lot of these little batteries basically built up into different packs. Its weight doesn't change throughout the flight, so that's, they're going to be heavier systems throughout their flight. They take a long time to charge, and there's a significant thermal challenge as well with batteries. So those are all things that industry is dealing with now too, because we're not, leading the charge on that. Although I think we're, towards the leading edge of battery technology on it, but a lot of industry is struggling with that at the same time. And I think some of the design changes we make is when we come up with a new design, it's open source on this thing, so everyone can see it basically utilize it for their designs too. And it's been leveraged in some designs.
Currently, what's the I guess the flight range of the X-57 as far as I guess time aloft?
Yeah, so it'll probably be about a 40-minute flight. We'll be being fairly conservative with that to start. Battery health and lifetime is based off of how well you charge them, how much you let them deplete. So we'll be very conservative with how much we let it deplete when we fly it the first time, because we want to make sure these batteries last long enough for us, and we don't really know how all that's going to evolve. So we'll be tracking all that. It's all data we're going to take. But it's probably going to be around a 40-minute type of duration, which doesn't give you a whole lot of time to do a lot of things. But for this particular application, we can get what we need done. But clearly, you're not going to go out and sell this then to the public, because in its current implementation, it's not very useful other than as a demonstrator and a certification basis tool.
What are some of the other maybe innovations that we might see coming out of the X-57 program?
So battery, I think, is one. Some of the displays, how you would have a flight display for battery health and time state of charge left. We're going to have some of that stuff that we're developing for this. I think that might be beneficial to the industry. Certainly, interestingly enough, the concept of an electric controller for a motor is very simple, yet trying to do one at this scale for this particular purpose is still quite a challenge. So I think some of the work we're doing on the motor controllers will also be quite useful for the industry. There's a fair amount of software running in there, because everything's all digitally controlled now. So even these motor controllers are digital controls. There's software running in there, so there's certification concerns with that. So I think that'll be quite beneficial. And then just the how you would manage a distributed electric system from a failure mode standpoint, right? So what kind of single failure and how is that all going to play out? As you can imagine, with a quadcopter, a single failure of one of the rotors is not going to be a good day. So you want those things to be manageable and robust, and how they'll fail. So I think we'll probably learn a little bit about that.
And again, as you mentioned, all of the research is open source. So the things that you discover in this program, and if they do have commercial applications, can be turned over to the industry to help further the electric powered aircraft that we see. Hopefully, we'll see fly more often at our local airport.
And are even now being turned over, right? Because we have a lot of our researchers that are going to a lot of the certification meetings, working with the FAA on the certification standards. And I wouldn't say we're advising the industry, but we're providing our info out to the industry, certainly. Very robust effort in trying to get out to the technical firms to talk about what we're doing.
Excellent. And Hernan, you are sort of I guess your part of the program is the new kid on the block. It's the unmanned aerial vehicles. But tell us a little bit about. You mentioned that you had flown the Predator and the Global Hawk, but what are you flying now with the X program at NASA?
Well, we're doing what we call US and the NAS. We're trying to integrate the unmanned air vehicles into national airspace, and we just recently completed a several-year mission where we were doing scripted encounters. I would fly a small UAS with a specific radar that we're testing and a display that was showing me where the traffic was. And we had a bunch of intruding aircraft, slow, fast movers, and we're trying to effectively and safely detect collisions. So these radars will be hopefully one day used in other unmanned aircraft, and industry is embracing that, and the FAA is closely watching as they come up with new regulations on how to let these aircraft fly in the national airspace.
So being with the on the regulation side, there's obviously some really big challenges that have come up, not only with the very small, almost amateur use, to the much larger unmanned aerial vehicles that are becoming more commercially accepted.
That's correct, and we like to do these little science experiments in our controlled environment there at Edwards. So we've got lots of little small UAS working in the airspace and big UAS. So it's really interesting type of stuff that we're doing, and everyone watches. And again, just like the X aircraft, we put that information out for industry to use and apply to safely fly these planes.
What are some of the other missions that you're currently flying?
I also fly the King Airs on airborne science missions, and we were getting ready to do a study off of the Bay Area, looking at different types of currents out there, trying to study that with some buoys and some boats. So they'll come back online. We're just got our schedule slipped a little bit, but there's a lot of interesting stuff I've done. As the UAS person, I've done a lot of airborne science missions in the King Air. That's taken me all the way up to the North Pole to study stuff. So it's pretty exciting stuff I get to do.
What are some of the other airborne science projects that NASA is working on?
In the UAS?
In the UAS or in conventional aircraft?
Well, we also have the X-56, which is a smaller UAV that we're flying, and that's looking at flutter, trying to suppress flutter. So it's a several-year project as well that's been moving along pretty nicely. And they're getting ready to start flying it in a few weeks, possibly. But again, it's brought down lots of aircraft in the past, so trying to understand it and suppress it is going to be the goal of that aircraft.
What do you see in the future of unmanned aerial vehicles? What's coming over the horizon that we may not be cognizant of?
I think there's so much stuff. We're still at the tip of the iceberg. It's incredible technology. They're getting more and more robust, and I think the leash is coming out a little bit more every day. So we're able to fly pretty much right now, pretty much all over the oceans where there's no populations. But I think one day we'll see us flying more over the yellows of the sectionals and being more immersed with regular traffic out there safely.
Overall, in general, and I'll just throw this open to the panel, what are some of your observations or feelings of the next, I don't know if it's necessarily the next big thing, but some of the technology breakthroughs or research that you kind of see coming in the next few years?
I think electric propulsion, we've touched on it with the X-57, but the other big thing that's right behind the X-59 is the demonstration that we're looking to do with electric propulsion, and we're talking big motors now. We're talking things that would be, big turboprops or turbofans with assisted either what we call serial or hybrid or serial or parallel hybrid motors. So I think that's a big one. I think you're going to see us looking into efficiencies, even on the backside of supersonics. Once we figure out what that thump is, you're going to see us looking to test to make supersonic flight more efficient. It's never going to be, as efficient as flying slower. But, there are things that we're pretty sure that we can do to make it more efficient, but there's no sense in doing it if there's not really a market there, because you can't go, fast over land. So there's a lot of other little things. Like over the years, many people don't realize all the tiny little increments that NASA does when it comes to the aeronautics. The winglets that are on airplanes. You watch all these engines. The diameter keeps growing and growing. And those airplanes are getting more and more and more efficient. And now we're getting to the point where all the little things we tweaked, now we probably need to do something that's just a little bit bigger. So other follow-ons that you're going to see is maybe some little more radical designs, things more like a blend-in wing body or things like a truss brace wing or something like that. So there's some other designs that are out there that, maybe boundary layer ingestion, when it comes to the engine. So there's other things that we've looked at that we think we can make airplanes even more efficient. But there's only so much money to go around. So, you gotta pick your battles and pick when it is that you're going to do them. And when, honestly, the technology is right. So I think there's a lot of interesting stuff there. The stuff that Herman was talking about on the UAS side, I think there's some really interesting things going on when we call resilient autonomy. And, how do you get people into these vehicles without having to be, 6,000 and 8,000 hour test pilots? How do you get somebody that's got 4, and they can still fly these things safely? So I think there's a lot of work going into some of that stuff as well. That's it's a little mini aerospace boom that's kind of been going on for the last few years, and we're excited to be part of it, and hopefully riding this wave for a while.
Anyone else have any thoughts that they have?
Bill summed it up very well. I do think one area also, and our outgoing associate administrator for aeronautics was very, very strong on this, is basically the next boom could likely be in the urban air mobility type realm, right? So there's a lot of companies that are looking at how do we get smallish vehicles that can very easily move people around in a very dense urban environment and be able to do it safely. And a lot of what NASA's we're trying to figure out how we can enable that, right? Designing one and building one isn't necessarily the way we can enable it the best. The way we can enable it is, well, how can we help people test it and make sure it's safe? How can we help it integrate into the environment, into the airspace environment without hitting other things, right? So that's where we're trying to make sure we're staying pretty agile with that, but we're trying to figure out where we can help the community with that. So that's a lot of another area that we're working with pretty big.
And any thoughts from the group on young people growing up, they like to be astronauts, but there's so many other opportunities within NASA besides the astronaut corps. Any suggestions or words of advice that any of you would have?
It's an awesome place to work. I mean, it's not really work if you love it. So, and I think every one of us loves our job. And honestly, when you wander the halls and see people from build, it doesn't matter if you're a lawyer or if you're an engineer or you're a test pilot, you're an astronaut, or you're the janitor. Everybody is excited to work for the meatball here. It's one of the highest rated places in government to work. There's a lot of people that probably could be making a lot more money working somewhere else, but it's a calling that I think everybody just kind of loves. The things you get to do, the projects, it's just amazing. I think Clue alluded to it earlier of, you're not moving around anymore, and I'm just amazed at the number of different things that I get to work on when it comes to this, and exciting. I think I hired all these guys, but Herman. But, so it's exciting, to get to make that phone call. I can remember, I think I told Clue that I said, I can hear you smiling over the phone when I told him he got the job. So people are excited to come and work here. There's a lot of opportunity for whatever it is that you want to do. And NASA's a great place to do it.
Yeah, I'd add to that what Nils said, that the big thing to get ready for it is not necessarily that you have to be, a military test pilot or anything else. Whatever it is that you're doing, do your best at it, work hard at school, and keep your eyes on the goal. I mean, I thought I wanted to come work for NASA when I was 4 years old, and I sort of gave up on the dream after I got to college and realized I wasn't going to be an engineer. But 20 years later, suddenly the job lands on my lap, and it just largely because I worked really hard, but also because the opportunities are out there if you're good at a particular field and you keep your eye on the ball and look for them. So keep aiming for it.
And Bill, I understand you'll actually be transitioning in your career in the next, I guess, few weeks or so. Is that right?
Yeah. I figured this might come up. In fact, I've decided that it's time for me to retire from NASA and go do some other things. One of the things I want to do is go fly some airplanes some more, which I haven't had a whole lot of time to do at NASA. So I'm pursuing my CFI, and I'm going to go do some glider flying and power flying probably as well, and spend some more time with my family, and probably write a couple of history books that I've been meaning to write, but I've been busy managing the history program, so I haven't had time to do that. But so I'm going to go do that. And if you're a PhD holding historian out there excited about aerospace, there'll be a job on usajobs.gov pretty soon for you to apply to.
There you go. And Bill, as the NASA historian, is there any, I don't know, a little story or tidbit that you have come across in your research and in your documentation that just sort of tickled your fancy about NASA's history?
Oh, there are lots of great stories about NASA and its history. I mean, you can go forever on things. But in terms of ex-planes and ex-pilots, since that seems to be the crowd here tonight, but besides me, so, the thing I think I like the most is the Neil Armstrong story about he was flying. He actually was hired by the NACA at what was then Lewis Fields, now Glenn Research Center in Ohio, and then wound up out at the Flight Research Center in the 50s. And he was flying test profiles for. I think his last flight was a test profile on the Sky Dancer for an abort mission from the Dinosaur. They would come off the rocket and have to try to abort back, much like we planned for the shuttle. But he applied to be an astronaut, and he actually applied late. But the guys in the astronaut office knew him and knew of his reputation. He had won a number of awards and done some great work. And so his application, even though it arrived late, somehow wound up in the right pile to be considered. And that's kind of how things roll here at NASA sometimes.
Well, gentlemen, just a few minutes left. Do any of you have any final thoughts or something that we've not talked about that you'd like to share with us? Just go ahead and jump in. Maybe Jim, we'll start with you.
Oh, I guess just echo the thoughts everybody else has had. NASA is a great place to work. You never really know where you're going to end up or what you're going to end up doing. 30, 40 years ago, I would not have anticipated that I would be out at Edwards and working as a test pilot for NASA. It's if you like airplanes, it's a great place to work. If you like space, it's a great place to work. A lot of the things we're doing now are actually combining the two. We are involved in testing things for the space program. A number of different examples over the years of control systems, parachutes for capsules. We may be involved in the upcoming lunar program. So it's a great time to work for NASA. It's a great time to be a kid just starting out. I almost wish I could start over at 15 and study engineering again and get into all this kind of stuff. So hopefully there's a lot of people out there that want to come work with us.
Great. How about you, Wayne?
Yeah, so we're really excited about what we have coming up and what the possibilities are. We're always looking for equally enthusiastic people to come work for us. And you don't have to be a pilot to work at NASA. You don't have to be an astronaut to work at NASA. We have all different types of jobs here, and everyone contributes towards the technology goal. So just take a look at what we got, and if you're interested in aviation, stay in aviation. If you're interested in space, try and get something, do the job in space. So that would be my advice there.
How about you, Hernan?
I get the privilege of talking to lots of kids, and I always tell them I actually didn't be at NASA, but here I am. So I would say just stick with your dreams. I ended up in the UAV world, and it's been a blessing. It's opened up so many doors. So just stick with it, and opportunities just come knocking on your door. Good time.
All right, and Nils?
Same thing. I mean, I said it's a great place to work. The other thing is, if at first you don't succeed, try again. I think Clue got in on his first try, and I think Herman got in on his first try. But Wayne and I did not get in on first try when we applied to be test pilots. So try again. Find some more education, more experience, whatever it happens to be. If you really want to come and work here. Bill kind of alluded to it before, set yourself up for there's a lot of great things to do at NASA. Before I got here, I had a lot of fun getting here. So, it's an awesome place to work. And, if first you don't succeed, try again.
All right. Well, thank you, all of you, for taking time to share your stories and insights with us. We certainly appreciate it. We'd much rather do this in person, but we'll reset that for 2021. And I wish you all the best of luck in your respective programs. And we look forward to all the new innovations and breakthroughs that come our way from NASA. So thank you again for joining us this evening. During the Ray Foundation Challenge, all new or increased gifts to the EAA Aviation Foundation will be matched up to $1 million. Go to eaa.org/Ray Challenge or text EAA Ray to 56512 to give now.